Welcome to the collector's edition exposition of the #1 ball killer, bar none. I've given everyone the afternoon off, so it's just you and me. Let's call it quality cowbell time. Pay close attention, then send this gargantuan death blow to everyone you know. There was a textual error in one of the photos in the last presentation. I'll identify that here in a few minutes. It has no material impact on the argument whatsoever. And a phenomenon that's happened quite recently, some knucklehead flat earthers have decided to wield this simple argument like a 3-month-old wields a Husqvarna chainsaw. So, I'll be going through this baller chimera each week for the foreseeable future. It's so utterly devastating, folks. I'm going to kill it with such ferocity it's going to make the $6 million man crash and burn look like a fender bender. What's really cool, besides Steve Austin blushing, the ease in which the calamity befalleth it. Many thanks to Ben, Taboo Conspiracy, for bringing it to my attention, and BMLSB69 for the boots on the ground. Before I pummel this disheveled monkey, allow me to lay the foundation of the entire argument. And it's really simple. The horizon. I've got 3 definitions here. One from their alma mater wiki, Merriam-Webster, and Oxford dictionaries. The horizon. It's the apparent line that separates Earth from sky. The line where the Earth seems to meet the sky, the apparent junction of the Earth and sky sailing toward the horizon. And finally, the line at which the Earth's surface and the sky appear to meet. It's just that simple. Why is it apparent? That is, not actually? Well, one is well duh, right? The sky never actually meets the ground. That's a big one. And number 2, it's conditional on weather, atmospheric conditions, waves, tides, etc. However, on the ball-tarred ball, the geometric horizon can be no more than, this is very important, critical, the geometric horizon can be no more than what its geometric constraints allow. It's based on the observer's height and the radius. Let's confirm that with the subject matter expert in the area, Andrew Thomas Young, San Diego State University Astronomy Department. If h is in meters, that makes the distance to the geometric horizon 3.57 kilometers times the square root of the height of the eye in meters, or about 1.23 miles times the square root of the eye height in feet. That's it, folks. Now, it can be closer, the horizon can be closer than this, but under no circumstances, under any conditions, can it be any more than 1.23 miles times the square root of the eye height in feet. Hopefully, everyone understands that. Without further ado, the death of the ball-tarred spinning space monkey religion again. Listen closely. If the Earth is a sphere with a radius of 3959 miles, then every horizon distance measurement must be no more than, that's a very important statement right there, must be no more than 1.225 times the square root of the observer's height in feet. That's the geometric horizon. Go to any curve calculator, that's the formula they use. What do we have right here? It's called the kill shot. We can clearly see the horizon behind platform habitat at 9.4 miles. It's over right here, folks. The rest is barely palpable background noise, but let's have some fun. So, the observer's height in this particular photo was 1 foot. Distance to the horizon, according to our formula, greater than 9.41 miles. Distance to the horizon maximum for a sphere with an R radius of 3959 miles, according to that formula, is 1.22 miles. You have some big problems right here. Now, one of the rebuttals, one of the objections was that BMLSB 69 was greater than 1 foot. Now, we're going to hammer that into the incoherent oblivion here in 1 second. However, even if he was 5 feet, his observer height was 5 feet, the maximum distance to the geometric horizon should be 2.73 miles. That means it should be before Platform Hill House, right? Even if he was standing on the shore with his camera almost in the water, at 35 feet, the maximum distance to the geometric horizon would be 7.24 miles. That is, it would be in between Platform Hill House and Platform Habitat. So that's debunked. Now for the next kill shot. Modus tollens. Holy shnikes, this is going to leave a mark. If P, then Q. Not Q, therefore not P. If the Earth is a sphere with a radius of 3959 miles, P, then any horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet, Q. Not Q. Why? Because the horizon distance was greater than 9.41 miles. Therefore, not P. The Earth is not a sphere. The ball-tard spinning space monkey community, please allow me to introduce to you the one you've known for all these years, your Sergeant Pepper's Lonely Hearts Black Plague, your Black Swan. Here is the final kill shot. This photo is impossible on their sphere. Let me say that again. This photo with the horizon behind the platform habitat is impossible under any conditions on their sphere. That's it. You can all go home. It's over. Now they're going to attempt, quite feebly I might add, to escape and evade, tap dance, and clumsily attempt to obfuscate using all manner of Mr. Magoo's sophistry. But I'm going to stamp them out with belly-laughing ease and extreme prejudice. So, let's take a look at some pedigree information. We're going to take a look at the original video from BLMSB 69. Now, don't worry about the no sound in the beginning. Just take it all in. I'm going to stop the video a couple times to emphasize a few points. Here we go. Platform Hill House. Going to identify it for you on the map. Next, platform habitat. Platform habitat there. He's going to orient you Platform habitat, platform hill house, observer's location. Let's get some distances, because that's all we need. That's all we're using these platforms for. Demarcating distances. So, platform hill house, the closest platform, 6.21 miles. Platform habitat, 9.41 miles. Pedigree information. This is the photo. This was the problem photo. He just mislabeled it. This says 1 foot elevation. This is incorrect. It's 30 feet elevation. It doesn't matter anyway, but I wanted to keep everything wired tight, so I took this photo out of the presentation. As you can see, it's the same photo. Let's get real. Couple things here. Obviously, he's pretty close to sea level, don't you think? I also want to get your attention over here to this landmass, right? Because we're going to pummel another rebuttal, quite feeble one, I might add, here in a couple minutes. This is Santa Cruz Island, and it's off to the right because the platforms are right here. It's going to be off to the right of these platforms. Let's continue. Kill shot, folks. DED. Dead. Curve calculator. One foot eye height. 1.22 miles to the horizon. Now, focus your attention to the right of the photo, please. Over by the boom. Here you go. This is the end of Santa Cruz Island. It abruptly stops. Quite a distance away from that right platform, correct? Focus your attention over here. Uh-oh, what's that? That's another landmass over here. That's Anacapa Island. There is about 4 3/4 mile distance between the end of Santa Cruz Island and Anacapa. What I'm trying to say is he is looking out into open water. And I'm going to show you that here in 1 second. Pretty close to 1 foot, don't you think? I mean, come on, people. All right. Let me orient you again. We're going to take a look at those 2 islands. We're going to take a look at the line of sight down the lane of the platforms and the 2 islands. Like I said, the one to his right is Santa Cruz Island. What do you see over here? Right? His line of sight, it was real close, right? But no cigar. And the island to the left, like I said, was Anacapa Island. And there's 4 3/4 miles between here. His line of sight from his position through these platforms is out to open ocean. So there is no land behind those platforms. Y'all tracking me? All right? Take a closer look in here. Platform habitat. In the lane, 5 by 5. Platform hill house. In the lane, 5 by 5. His position. right? It's pretty close. I'm pretty close in there. We're going to take a closer look here. I don't want to go down the street view, so I'm being real careful for you. That should be just about good enough, right? Let's take a look on where he's at, and we'll come back here. Because he's going to get up and turn around. As you can see, this is the stairwell. He is just right to the stairwell, and as he walks up here, about 18 paces, he's going to shimmy to the left a little bit to align with the stairwell. Let's take a look. Right, there he goes. He's shimmying to the left a little bit. Align himself to those stairs. Right? Quite interesting. And what do we got here? Right? We got those same stairs right here. I got him just over to the right of the stairwell. This is 1 foot elevation. He's going to start walking up 7 or 18 paces. He's going to shimmy to the left and align himself with these stairs. Let me tell you something. If BMLSB 69 would go back to that same spot that he took these photos from, and I put a firecracker right at the end of this red line, I'd blow his toe jams out. Anyone willing to make that bet? I didn't think so. So, potential debunks. We already took 2 to the woodshed. The first one was BMLSB 69 isn't 1 foot elevation. Well, kind of is. I'll tell you what. I'll give you 1 to 3 feet. No problem. It doesn't matter anyway, because I took this to the woodshed in the beginning. He could have been 5 foot. He could have been at 35 feet at that same position. It matters not. Number 2, there is land or islands behind the platforms. Clearly, I showed you when we were keeping it real and with Google Earth that that's not the case. Number 3, you can't see the horizon. One of 2 things is happening here. Number 1, you need to remove the baked-on cognitive dissonance mud from your eyes. And or number 2, make an ASAP appointment with the ophthalmologist, because you're dead blind. Everyone can see, just to let you know, if you look at this photo and you say you can't see the horizon, you're a horse's ass. Because I don't care. If you're legally blind, I still think you can see this horizon. You tell me. This is the kill shot. This is the Black Swan. Oh, number 4, the white swans. This photo was taken 2 months, same position, same observer height, same camera, same everything. This was taken in December, so 2 months after the Black Swan, right? No problem here, right? The sea was angry that day, my friends. It doesn't matter, though. Remember the argument. The horizon cannot be greater than that ratio of the observer height on a radius of 3959 miles. So this is before. It's fine. It's before the second platform. There's atmospheric shenanigans going on here. That's okay. No problem. This photo was taken 4 days after. This white swan was taken 4 days after the Black Swan. Again, no problem. Now, I watched this video. It doesn't seem that he was 1 foot. It seemed like he stood up and took this picture. It matters not, right? This is what they call a white swan. Does this observation debunk the number 1 globe killer? But this is a white swan. Does it debunk the Black Swan? No. It has nothing to do with it. You can show me 5 billion pictures or photos with the horizon before these platforms. Doesn't matter. All I need is this one. That's it. You follow? Probably not. You don't get the argument, ballers. That's the tear-jerking belly laugher. Right? It's going to be about 9 months until you can actually restate the argument. right? That's my first mission, to get you guys to actually restate it word for word correctly. It's only a sentence. I'm thinking 9 months. All right, so the white swans are dead. And number 5, we all know it. Refraction, right? Refraction saves the day. Gravity, refraction, right? Yeah? That's what you got, eh? You guys don't even know what refraction is. You don't. We all know you don't. Been out here 5 years. One of the first words I heard was refraction. You guys don't know what it is? Just yesterday, from a prominent baller, he was put to task with providing the 5 effects of refraction, right? Because people have been listening to the flat earth debate. You know what he said? There are no 5 effects of refraction. Oh, really? Your alma mater, atmospheric refraction. Let's read it together. Near the ground produces mirages. Such refraction can also raise or lower, stretch or shorten the images of distant objects without involving mirages. So we'll go by the numbers. 1, 2, 3, 4, 5. You get it yet? Let's try it again. This time, Wiki's going to parrot the subject matter expert, Andrew Thomas Young, our favorite guy. Let's go through it. While mirages are best known atmospheric refraction phenomena, looming and similar refraction phenomena do not produce mirages. Here we go. Mirages show an extra image or images of the mirage object, while looming, towering, stooping, and sinking do not. No inverted image is present in those phenomena either. Depending on atmospheric conditions, the objects can appear to be elevated or lowered, stretched or stooped. These phenomena can occur together, changing the appearance of different parts of the objects in different ways. Sometimes these phenomena can occur together with a true mirage. Let's count them together. The 5 effects of refraction. We ready? 1, mirages. 2, looming. 3, towering. 4, stooping. 5, sinking. You get it? Now, let's take your feeble refraction and go through each one in the context of the Black Swan and see if it fits. Why don't we? So there are 5 effects of refraction. So is the horizon miraged? Remember what mirages are. Mirages show an extra image or images of the mirage object. So is there an extra horizon in the Black Swan photo? Is there an extra horizon or horizons in this Black Swan photo? No? Then it's not a mirage. Get it? 1 down. Let's take towering and stooping together. From Wiki, however, this is also from Andrew Thomas Young, the subject matter expert. Towering and stooping change the apparent shape of the object itself. With towering, objects appear stretched. With stooping, objects seem to be shortened. Is the horizon stretched or shortened in the Black Swan photo? Is the horizon stretched or shortened? This is non sequitur. Okay? So there's 3 down, 2 to go. Sinking. From William Humphreys, Physics of the Air. Sinking is the opposite of looming. In sinking, stationary objects that are normally seen above the horizon appear to be lowered, or may even disappear below the horizon. In looming, the curvature of the rays is increasing, while sinking produces the opposite effect. Is the horizon lowered or disappeared below the horizon in the Black Swan photo? Does the horizon disappear below it, or is lowered below the horizon? Non sequitur fallacy again, isn't it? You only got 1 left. Looming. From their alma mater Wiki. Looming is the most noticeable and most often observed of these refraction phenomena. It is abnormally large refraction of the object that increases the apparent elevation of the distant objects and sometimes allows an observer to see the objects that are refracted or that are located below the horizon under normal conditions. Let's take it from the subject matter expert, Andrew Thomas Young, San Diego State University. Looming, the appearance above the horizon of a distant object that would normally be hidden below it. We'll get to the rest of it here in a minute. All we need is this. Is the horizon appearing above the horizon in the Black Swan photo? Is there a horizon appearing above the horizon in this photo? No. Then your silly appeal to refraction is clobbered to death. You don't know what you're talking about. You understand that? My word, people. So we're gonna take this further to the woodshed. Just let me remind you, the freaking horizon doesn't ever loom. Ever, ever, ever. Now, let's deal with the second half of this, because this definition, even in their fallacious definition, they're wrong. But this is an incorrect definition. I'm going to show you this step by step. Here's the first step. For looming, this effect is caused by unusually large terrestrial refraction. Usually due to a thermal inversion, looming is the opposite of sinking. Both are refraction phenomena, but not mirages. See the table of refraction phenomena, la, la, la. I really don't care. This effect is caused by unusually large terrestrial refraction. You got a problem, folks, because it's a fallacy. This is a stone cold, this little game right here is a stone cold begging the question fallacy. How so? Does light refract? Answer, yeah. Is that the same that can be accounted for by terrestrial refraction? Answer, nope. Why? Keyword terrestrial. You see, terrestrial refraction already assumes a sphere. That is, the calculations assume the radius of the Earth curvature, right? He even says it. The subject matter expert even says it. What are you going to do? Let's listen to Andrew Thomas Young again. Here he goes. The atmosphere is also curved. Yeah, right. As it follows the shape of the Earth. Gases don't form curves permanently. Just to let you know. Let's start over. The atmosphere is also curved, as it follows the shape of the Earth. In the calculations below, we'll adopt the rough value of 6,400 kilometers as the radius of curvature. To make the calculation simple, you can't do that. You see this, Professor? You're assuming the premise, the atmosphere is curved. You're snorting some pretty good shrooms. Then by proxy, the Earth curvature. To prove the conclusion true. That is terrestrial refraction or looming. It's a textbook begging the question fallacy. It's a circular banjo-do-si-do. The entire argument is dead right here. It's void. Yeah, but we're not going to stop there. Where's the fun in that, right? Let's take a look at this. So, we have Andrew Thomas Young's definition of looming, and then we have quantum eraser, Andrew Thomas Young's huckleberry. Let's see which one's correct, with examples. So, from Andrew Thomas Young, looming. The appearance above the horizon of a distant object that would normally be hidden below it. Keep that in mind. From quantum eraser, looming is nothing more than an optical illusion produced by the sky being inferior miraged underneath an object, giving you the appearance of said objects floating above a false horizon. Let's see which one of these two have some cowbell to it. All right? We'll stop here quick at Wiki. This is Wiki looming. This is nothing. This is just a blurred photo of ships. All right? Clowns. This is the quintessential example of looming. Right? And I showed this during the last presentation with a little trick. In the military, they taught us for night operations to use off-center vision. You can see better. I knew that long before the military because I did a lot of night operations before I got in there, but I digress. So what I want you to do here is I want you to look right up here, follow this along, focus on here, and you can see the horizon in your off-center vision, right? I can see it clearly, right here, right near the bow, Everyone see this? Right? So we got a false horizon right here. We have the sky being inferior mirage down here, right? And it produces looming. Whose definition is more correct? I wonder who. So we have Mick West to the rescue, right? Mick always comes to the rescue if we find ourselves in trouble. So, but Mick had a legitimate complaint here because the media was calling this same photo, right? This same photo, he took it right here. They were calling this a Fata Morgana. Now, he was right for calling them out because there is no inversion here. This is not a mirage. He's correct. He also identifies the real horizon here for you. He uses contrast. So you don't have to use your off-center vision. It's right where I said it was. Right? He also identifies the false horizon. Don't pay any attention to his shroom-induced reason because he said it was due to fog. Now, let me ask you something out there. If this was a fog bank, could you see the boat? My word, people. All right, this photo was taken, another example of looming. This photo was taken in 2014. It was the Scottish Open. Now, don't look at this photo over here to the right. Don't worry about this one. You don't even have to use off-center vision with this photo, right? You can see the horizon. I can see it clearly, right? But they go ahead and color correct over here, which makes it very clear. Whose definition is correct of looming? You got the sky being inferior miraged beneath this boat, which is giving you a false horizon, right? Whose definition is correct? Andrew Thomas Young or QE? This is probably the best example of looming I've seen. Betty called it, as soon as she seen this, she said the boats were being raptured, which I thought was hilarious. It looks like it too. However, even in this photo, I can still see the true horizon. It's real easy. You don't even have to use off-center vision here, right? Don't have to use it. I can see it. It's right there. This is a great photo, right? Now, whose definition is correct? Because we have the sky being inferior mirage beneath an object, which makes it appear to be lifted up or floating, right? You can see that the sky's being reflected here. You can see the clouds here, right? It's a collage, but you can still see them in here being reflected down, right? This is a no-brainer, man. There's the false horizon right here. Whose definition is correct? Andrew Thomas Young's or QE, his Huckleberry? Yeah, that's what I thought. I mean, this is a joke, folks. A joke. Now, let's go back up. I want to go through the argument one more time. It's going to be quick. Now, if you see this argument, let's go to this. If you see this argument presented by anyone in any other form than what I am going to lay out and did lay out before, that is word for word, including this modus tollens, with the exact same photo, it is not the argument. Is this clear? Is this clear? Let's go with the argument. Modus tollens. If P, then Q, not Q, therefore not P. If the Earth is a sphere with a radius of 3959 miles, P, then any horizon distance measurement must be no more than 1.225 times the square root of the observer's height in feet, Q. Not Q, because the horizon distance is greater than 9.41 miles, therefore not P. The Earth is not a sphere. It's their Black Swan. It's the kill shot. It's over. Now, like I said, if this argument is presented and doesn't go over each thing I said, it's not the argument. I don't want to have anything to do with it. I'm not signing off on it. Is this clear to everyone? Hopefully so. Now, can I please have everyone stand? For you soldiers out there, on your feet. Please remove any headgear. Do not rest in peace. spinning water ball, but in tortuous agony forever and ever you so richly deserve.